So we'd like to open up for some questions from the audience.
So I'd like to go back to the K-12 use of it and the idea of doing design thinking. So to what extent, I guess the question is the professional development for the teachers, and to what extent they're able to use these spaces and connect to engineering with or without professional development. What do you find that they need?
Yeah, so absolutely. You guys can hear me.
You have to press the button.
Now is it on? Oh, got it. So the professional development of the teachers in the K through 12 school, right? Yeah, we absolutely have to have in the Eureka Lab, in the makerspace of the school, you have to have staff that is ready and able to train the teachers, because the teachers want to feel comfortable on knowing what a laser cutter is and what it does and how it works before they send students to go use the darn thing. And we found that just 1 or 2 hours are helpful to setting up these sort of consults with the teachers and training them. And then the teachers can come in and maybe they don't know it to the level that the shop staff would know it, but they feel comfortable enough to guide the students in what the laser cutter can do and how they can use it for their project. Second one?
Yeah, but I guess I want to go beyond that to the idea that they don't know, a lot of them have not had training in engineering. They don't know
Right.
what design thinking is. So are they able to use these tools effectively with the kind of training you're talking about? And to what extent do you give them professional development around what design thinking is?
Great question. November 13th, I have a professional development day. The school is great, right? So I can walk in and I can have a 2-hour professional development with the entire faculty and teach them the basics of design thinking, teach them how people are using it, and we're gonna have little talks where the existing teachers that are already doing the design thinking units, we started with the science teachers, they were the most open to it, right? Makes sense. And having them give a 2-minute pitch of what they're doing, we've learned that the teachers want to do it and they're not as intimidated by it once they learn that some other teacher has learned it and started it themselves. So that word of mouth has propagated the most. So yeah, some teachers we took to the Nueva Design Thinking Institute. That's a big check to write. Some teachers, I come in and I do a faculty development day.
I have a request to please use the microphone. So gentleman right here, but there's a microphone right behind you.
Hey, my name is Wahid Bajwa. I'm from Rutgers University, Electrical and Computer Engineering. A great presentation. We have been thinking about having something similar at a very small level, but haven't succeeded yet. So my question was regarding that process that you guys have gone through. I mean, it's clear that the 3 makerspaces that were introduced, they have been very popular. What I'm thinking is, like, do we all have to sort of learn on our own, or is there some sort of a way that, you know, there is a central repository that sort of documents these things, that maybe like people can come together and really learn? Whereas rather than going, okay, you know, let me try this, oh, this didn't work, and then I come and you say, oh, actually, you should have just asked me, but I didn't know you existed, kind of thing, right? So I hope my question sort of makes sense, right? It's like, where is a central repository? Who is taking up the lead? I don't know, NSF, NAE, some other leaders, which is like documenting the best practices. This is what works. This is what doesn't work. If you have millions of dollars of budget, this is how you should do. If you have hundreds of dollars of budget, this is how you should do. You know, I mean, I'm serious, right? I cannot, you know, extracting $1,000 out of a public university. I think Daryl will agree with me. You know, it can be
no, it's easy
thing.
for Daryl. You just ask.
Okay.
He'll take care
maybe
of it.
I'm giving the wrong example. You know, I'm in New Jersey. We have a really hard time. You know, we you know, I don't know if I should talk politics here. So
Yeah, let's turn over to one of our panelists.
But hopefully that makes sense. So if, you know, something like that, who should be responsible for that? Thank you.
Yeah, so I'll take a stab at this one. So last year, this was really what the driving factor was in us going through the U.S. News and World Reports and trying to find schools that had maker spaces and try to pull out what they're doing in those environments. And the landscape is scattered, and what people are publishing is all over the place. But the reason I said I think that's outdated is because by the time that paper went to press, there was and there is a Make Schools, I think it's makeschools.org, and it's pretty much a national repository of projects, equipment, spaces, and people that are using makerspaces across the country. It's relatively straightforward to navigate. It has a lot of great information in it, and it's, at this point, I've been there many times over looking at the different projects that people are doing in their spaces. I think it's a really great resource. I think it's makeschools.org.
I'm just going to add very quickly that a lot of schools also go and visit other places. So I've had 35 different schools at least in the last 3 years visiting. I think one of the challenges is that what model works for one place may or may not work for another place. So I think every group is still going to have to figure out how to do it in their particular ecosystem. But there isn't anyone I know that is running a space like this that isn't willing to share.
And I just want to quickly add, last at the ASEE this past summer, the American Society of Engineering Education, there was at least, there's so many publications, but at least one professor from Yale University tried to do a comprehensive study of all makerspaces across the entire nation. So I think you could look that up in the Journal of Engineering Education. And I was going to invite also all of you. Could I just see a show of hands for who has a makerspace already on their campus? Okay. Could you raise your hand if you don't, but are in the planning of it, in the starting of it? Okay. We should have asked that earlier, huh? Mm-hmm. Okay. And yeah, of course, the invitation is to always, email me if you'd ever like a tour of MIT or any of our spaces. I'd be happy to.
Okay, we've got a question over here.
Hi, I'm Doug Holmes from Boston University. And I was curious, a lot of the focus seemed to be on kind of giving these students tools as ways to solve innovative problems, make things, come up with new solutions to things. But there wasn't much of a focus on kind of reverse engineering classical solutions to problems. When you talk about tinkering, are there things in these makerspaces, like the classical gear mechanisms or things that they can kind of play with and tinker with that are well-established solutions so that we're not always reinventing the wheel at times?
I would say yes. What we ask our students to do is solve challenges. Doesn't mean they have to use everything that's completely new and innovative. They're not doing research. They're not identifying completely new concepts. So we strongly encourage them to use existing solutions, transfer them to other places, be innovative about that. And we have opportunities for them to do take-apart labs where they really can see how other things are made. So I think that's an important piece of this, and I appreciate you bringing it up.
Okay, so we have a question coming up from the front, and then we'll get the gentleman on the side.
Hi, I'm Leslie Kalman. I'm with an organization called Engineering World Health. The question's for Robert. You talked about culture, but you didn't actually define it. What aspects of, what do you mean by culture when you talk about the culture of the space?
I guess for me, the things that I'm really interested in are the norms of the behavior that are going on in the space. I see a lot of informal leadership and society growing in the space. There are the ways in which the people are interacting in the space. So something that the students that we have had go in have discussed are have written about in their field notes and then discussed more in their narrative, are how when they enter that space, the feeling that they get or the way they're introduced, for me, those are very key pieces of the culture. And the differences between those, I think, are also very key pieces. And so I've got one young lady and one young male, and they have very different stories and very different narratives and very different experiences. So for me, those are the pieces that make up culture. And I think as an engineer putting a definition on it, it's the norms and the behaviors in that space.
Back to you, sir.
Elliot Douglas, National Science Foundation. This is more of a comment for everyone. want to let you all know, if you don't, that NSF has a Dear Colleague letter seeking proposals on making. And if you want to find it, it is NSF number 15-086. And I am the engineer, the contact from engineering for that. So if you have questions about it, you can let me know. Come see me.
Great, thank you. Yeah, can we get a mic up to that middle row? Since there are two questions in there.
Great, thank you very much. I'm Diane Seaver, University of Colorado Boulder. My question has to do with informal versus formal learning. What is the proportion of formal classes that are using the space versus students who are able to wander in and generate ideas, put together teams, get funding to put together a project, and what's your philosophy behind that?
I could quickly respond that MIT has so many, like literally over about 100 probably makerspaces. Some of them are meant to be used for the classes that are running, so it's almost like at capacity because during the semester there's a full class running there, and then in the next semester there's a whole nother class. But we also have other makerspaces that are meant not for classes, so they're purposefully for students that don't have classes and just want to tinker or make or pursue entrepreneurship. We have a new partnership with the Entrepreneurship Center, and it produced a MakerWorks and a ProtoWorks, and this is mostly, so the priority of access goes to the students that have some kind of startup or entrepreneurship idea that they need to prototype to get out there. And then the hobby shop is a place for people that don't have any of these. And then the MakerWorks is biomechanical engineering students, but for whatever use. So I think it depends on what the purpose of that space is for, so that you don't have anybody running on anybody's turf. And I think that works well when you know that, oh, I have a class to do it, I go here, and I have a not so class to do it, and I go somewhere else.
In our situation, we're primarily curricular-based or clubs. Of course, once a student has access, there are lots of things that they can do in that facility, but with limited resources, we're really focusing on curriculum and clubs. And my particular university is very sensitive about their nonprofit status and wants to be very careful about students coming in and using university resources to create something that they're going to sell. So there's some sensitivity around that.
Yeah, our on-the-record answer for that would be everything is curricular. But what the truth of that ends up being is that the students know that, and they figure out ways to couple it back, their interests back to the curriculum. It's very common for our students to come to faculty members and say, I've got this great idea for an independent study project. Would you sponsor me for the semester so I can work on this particular project? And then they work with that faculty member and they have access to those spaces, and they're doing different things in and out of those spaces for however long that project goes. And sometimes they're a semester and sometimes they're years.
Dirk Ronald, University of Colorado. Department of Computer Science. So in the example from MakerBot, in the talk that was given, one of there was the interesting distinction between the physical device, the thing that makes and was made, plus then the ecosystem, which includes a tremendous amount of computing and design and data recording, so Thingiverse and so forth. How do your makerspaces include tasks like computing or Internet of Things or logging things from medical devices? Is that being done, and how do you foresee trying to address that?
So we very purposely try to have resources for all kinds of projects. So one of the things that we've done is have a computer lab that's very specifically a collaborative computing environment. So our computer science students who are working on developing for a particular company, they're developing a software package. They can work together, they can each be working on different subroutines, but they can then do a common display. So there's some things you can do just with the facility to make it possible for these students to work in teams on authentic challenges that don't happen to be making a physical prototype. The area where I've been, I'd say, a little less successful is taking students that are in the disciplines that might be doing more computational-based work and pairing them with teams that also are building physical prototypes. And it's an area where I'm getting more and more interest from our faculty, But if you think about this, curriculum lies within departments. And so you can't tell, one department can't tell another department what might constitute their capstone. So those are sort of, I look at those as opportunities. And in a sense, every year I keep a little budget back for these new ideas and try to then be ready with some funding so that if there's a new idea that we need some resources to be able to implement, I'm kind of there waiting and ready for it.
So,
Yeah, in the
Virginia
back, please.
Davis, Auburn University. So my question is kind of similar. The idea of having cross-cutting interdisciplinary design teams and design throughout the curriculum is wonderful, but how do you implement that with the constraints of time and space and schedules? I think that, you know, many engineering departments have seen very large growth over the last 10 years where senior sequence has gone from 50 to 100 or more in a major, and then if you want to pair, let's just say chemical and mechanical and electrical, when they all have full schedules that compete and you're already constrained just with your own discipline, how do you effectively, like just logistically in terms of timing, get those people physically in the same room at the same time?
So I can start by answering that. So first of all, it's a very long process. It also requires faculty who want to do it and departments that want to do it. So what I can say is those faculty that have chosen to go this route are folks that really are engaged and interested in providing good education for their students. And we've had to let some things go. So for example, each of us went back to our departments and said, you know what, we have created this collaborative course. And to do that, we had to take out this and this. Department, please take those pieces and put them somewhere else in the curriculum so that we can have this collaborative class. So it's very deliberate. It started with 2 departments. After a couple of years, a 3rd department added, but they didn't want to make their students come to class at 8:30 in the morning. And so they mirrored the course and they did it at 1 o'clock. And after a year and a half of that, decided that was stupid and then moved it to the same time. So, you know, we've just been incredibly flexible as we could possibly be. There are some departments that have no interest in participating whatsoever. And I don't look at that as a failure. I look at that as an opportunity. And at some point, so instead of collaborative capstone, then are there some mid-year programs that the Design Kitchen can offer that would meet the needs for, let's say, chemical engineering students or civil engineering students that right now don't participate in a collaborative capstone. And honestly, I'm a firm believer that the faculty in the department have to make the choices for what is the curriculum for that department. What we can do, though, is if I put on my director of the facility hat, what I can do is make things easier if they want to go in this direction.
Another strategy that worked for us is our mechanical engineering capstone was so awesome that students from other departments want to take it. And as long as you allow that capstone in Mechie to count for the electrical engineering students' capstone, then that crossover is fine. That's another strategy.
So I can echo what Maria said, actually. It takes time. I am currently teaching a class with our occupational therapy program, and it's a cohort model class. Well, for them, they're a cohort model, so all the students come in, and there's different things in all the classes that tie back to their accreditation that they have to have. And so it took 2 years to figure out how to move the pieces out of their assistive technology design class that were required for their accreditation so that the engineering students and the engineering content could be brought into the class and we could co-locate the two. And so from the engineering side, it was quite simple. We could offer a technical elective and we could run it outside of the normal blocks of time that the students were actually going to be in their engineering classes. But from the OT side, it took quite a bit of time and maneuvering and trying to figure out where to put things so that they could let that happen. So.
Okay, last question, please.
Hi, my name's David Isidore. I'm from University of Pennsylvania in the bioengineering department and also the electrical engineering department. So my question is, makerspaces, it's super inspiring. You see how the students are learning from each other, and it's open-ended, and they're really driving you with their curiosity. But there are many subjects we teach that are sort of not obviously amenable to these kinds of makerspaces, like microfabrication and chemical engineers doing these large-scale design of chemical plants. And I'm really curious, what we can take from these successes, and are there any ways to broaden that and think about these, other types of things we want to teach our engineers to do, where they can't make it with a 3D printer or laser cutter.
So I would argue that every engineering discipline should think about some laboratory courses that are open-ended. They might still have to happen in a lab, and they may have some constraints that are not there with open-ended design challenges. But to have your students work on a lab exercise that's not a cookbook exercise, so that at the more senior level, they're making more of the decisions. And if they make a mistake, the experiment doesn't work and they have to start over. Those are really good skills, and it might be a way of kind of marrying. So for example, you mentioned microfluidics, or you mentioned some other techniques. Maybe a way to do it is to have a laboratory course that's somewhat constrained, but you make parts of it as open as you can.
I would say that for me, it's about the process and understanding how, like, you're using the scientific process on that gradient design thinking process, on that gradient maker movement type things, endeavoring in whatever field of engineering. So that's why the process is really what stands out for me. I would encourage you to look up two things. One is BioBuilder. It's out of MIT, and it's the way it's becoming a makerspace in the community. So she's using really interesting techniques and needing a makerspace type space for her lab materials and teaching chemistry through chemical engineering. And the second thing I would have you look up is it's Lego RNA, Lego DNA, Lego protein building, also out of the Edgerton Center, and how the mindsets of what you make with Legos and the way you learn has become a different way of learning about protein molecules.
Thank you.
Okay, one last question back.
I'm Mel Gomez from the University of Maryland. And let's see, we all have very rigorous programs, ECE, civil engineering, et cetera. And on top of this, we're asking students to form collaborative groups to create maker activities and so on. And so we're really asking a lot from our students, which is, I guess, okay, because there's 24 hours in a day. Which brings me to my point. What are the legal hurdles, and how did you circumvent the legal hurdles and the financial hurdles associated with opening up labs 24/7? Because I think it's key.
Again, back to some things are going to be local decisions. So what we did was we really focused on safety first. And there are certain things that are not available 24/7, right? Students can't go into the machine shop at night alone. And so that part of the building is locked. But we try to be as open as possible. And then we worked with our university risk management system to make sure that everybody was comfortable with that up and down. And then I tell all of my students, this is a really, really amazing opportunity for them, but it's not a right. And if they mess up, then it's going to have to be locked. And their ability to get their work done is really predicated on that 24/7 access. Right? They don't have time to work in the mornings, they're in class. In the afternoons, they're in labs. So evening and night hours are critically important to them. And so I'm just constantly reminding them that this is something that is a gift, and that we're only probably one accident away from not being able to do that. And so we're constantly harping on safety while we're there during the day. And then our lab assistants, who are there more often later hours, their number one responsibility is safety.
So we have not been able to actually get 24-hour access to our facilities. So we're open till, I think it's 11 p.m. And we open, I believe it's somewhere like 6:30 in the morning is when the building's open. Saturdays, the building is generally locked unless there's an event going on. And Sundays, it opens, I believe, at 11 and goes till 11. And so there is not 24-hour access. Some spaces are in lockdown when the building is open, and it's not during business hours. So that's the machine shop. The spaces where we have our fabrication equipment, we TA them if we want them to be open. And we have a TA who sits in that space until 11 p.m. and is trained on all the equipment during the high build times of the semester. and that guarantees there's always 2 people in that room. The other spaces that we feel the students can come in and out of freely, so like the creative spaces, the space with the MakerBots, we don't have TAs on there, and the students do just come and go. They have swipe access, but at 11 p.m., they're generally going to be asked to leave, and that was the negotiation and where we were able to come to with our risk management.
And 2 more things we've done is we have a buddy system so that when you're in there at night, you have to be in there with someone else. Simple stuff. If they go to the bathroom, well, then just hands off. And if they come back, then you can keep working. And the second thing is we have cameras in the labs. I don't know that we check them all the time, but they work, and they know that they work. And so that's a way for us to know you can't be silly here at 3 in the morning, or else that won't be possible anymore.
Okay, please join me in thanking our panelists.